Foundations, concrete formwork. Foundations, concrete flatwork forms, vertical forms, concrete stair forms, foundation damp proofing, and termite control. Concrete formwork is usually the responsibility of the carpenter, whether constructing wood forms or erecting a forming system. The forms must meet specified dimensions and be strong enough to withstand tremendous pressure. The carpenter must know that the forms will be strong enough before the concrete is placed. If the form fails to hold during concrete placement, costly labor and materials are lost. Formwork is unique in construction in that if it is built for a specific purpose, then it must be dismantled after the concrete cures. The carpenter must keep this in mind when designing the joints and seams in the formwork so that the materials can be taken apart easily and salvaged. Objectives. After completing this unit, the student should be able to describe the composition of concrete and factors affecting the strength, durability, and workability. Safety reminder. Concrete is universal building material used to support various structures. It must be handled and properly supported during placement. This is particularly important because concrete can be worked for only a short time before it sets up. Avoid prolonged contact with fresh concrete and wet cement because of possible skin irritation. Wear protective clothing. When working with newly mixed concrete, wash skin areas that have been exposed to wet concrete as soon as possible. Describe the composition of concrete, factors affecting the strength, durability, and workability. Explain the reasons for reinforcing concrete and describe the materials used. Job, mix, and batch of concrete. Explain the method of and reasons for making a slump test. Explain techniques used for the proper placement and curing of concrete. Construct forms for footings, slabs, walks, and driveways. Construct concrete forms for foundation walls. Construct concrete column forms. Lay out and build concrete forms for stairs. Estimate quantities of concrete. Describe methods of damp proofing a foundation. Describe how termites and fungi destroy wood. And state some construction techniques used to prevent destruction by wood pests. Foundations and concrete. Chapter Foundations. The foundations is the structural part of the building that touches the ground, supporting the entire building. It is positioned if an excavation and protrudes from the ground surface at least 8 inches. It is made of material that withstands the effects of water, heavy soil, rot, and decay. Masonry is the material most often used for this purpose. Foundation styles. 3 basic styles of foundations are used for residential concrete, the choice of which is used depends on architectural desires of soil conditions. Full basement foundations. Full basement foundations are made when a basement below grade is desired. The sidewall extends below grade to a point where a full height basement of 7 to 9 feet is achieved. A slab is then placed at the floor to the first floor of the building and then built at the top of the foundation wall. Crawl space foundations. A crawl space foundation does not have a living area below the first floor. The side walls are short, extended only to stable soil. Access to the bottom of the first floor allows for mechanical repairs and alterations that might be necessary. The bottom of the floor system should be at least 18 inches above the interior ground level, and beams and girders should be at 12 inches minimum. Slab on grade foundation. The first floor may be a concrete slab placed on the ground. This is what commonly called slab on grade construction. This is a style is often used in warm climates. Slab on grade construction. I believe that's monolithic, poured flat, where frost penetration to the ground is not deep. Improvements is the method of construction, the need for lower construction costs, and the desire to give the structure a lower profile. Slab on grade foundations are being used more often in all climates. Insulation is installed around the perimeter to prevent frost penetration. Electrical and plumbing below floor level must be done before concrete is placed. Foundation conditions. Foundation styles vary with conditions. which are a local issue that should be considered before building begins. The soil must support the building without moving. Most soil is adequate to support residential buildings. Unstable soil or soil under large commercial buildings must be assessed by engineers to determine what type of foundation is required. Foundations extend to the ground to rest on stable soil. Areas of cold weather require the foundation to begin at the level below the season of frost penetration. This is due to the fact that moisture expands when it freezes. This can cause the foundation to heave and buckle, thereby failing. The foundation must rest on soil below this depth, called the frost line. In extreme northern climates, this boundary can be 8 feet below the surface. In tropical climates, footings only need to reach solid soil, with no consideration given to frost. In regions where the soil is not stable, specific foundations must be installed. For example, the soil in south central United States can be predominantly clay. The soil will shrink and swell as much as 6 inches over the course of a year. This is caused by the natural wet to dry seasonal change of solution. The 3 basic styles of foundations: full basement, crawl space, and monolithic slab. Crawl space foundation, full basement foundation, slab on grade foundation. Is a foundation made with trenches for concrete and steel bars to allow the building to rise and fall as one unit. This is generally referred to as a reinforced concrete slab. The steel bars may be encased by a plastic tube so to allow it to be pulled tight after the concrete cures. This process is called post-tensioning and puts extreme stress on each bar. Foundation alternatives and foundation types. Other types of foundation exist to meet various industry demands. They provide the structural support necessary for building while having different characteristics. Concrete block foundation. The concrete block foundation is made by stacking together concrete masonry CMUs. In an array, CMUs are typically placed in a staggered bond where the vertical seams in the CMUs are not aligned one over the other. This provides maximum strength to the wall. CMUs are sometimes called concrete blocks or cinder blocks. They come in regularly and lightweight versions with varying widths. They are measured 8 inches high and typically 16 inches long. Some are 18 inches long. Each measurement is slightly smaller to allow for 38-inch mortar joints. CMU widths range from 4 to 12 inches in a 2-inch increment. Most CMUs are called stretchers, which have the familiar shape of CMUs. Some are constructed with flush ends for building square openings and corners. They are called sash or corner blocks. They also have a slot midway for easy splitting to make a half block. Installations of a CMU walls begin at the corners on top of a slab or footing. Several courses are laid up in the step arrangement. This is called a lead. The non-string is pulled tightly from one corner to the next on top of the first course. CMUs are installed along the line. They are continued until the wall weight is achieved. In variations to the system is insulated CMUs. It is made to 2 pieces that do not touch, separated by a layer of expanded polystyrene. This system created a thermal break between the... Ooh, look what we have here. Extreme frost penetration in inches based upon state averages. 36. Frost line penetration in the United States. Frost line penetration, okay. Reinforced concrete slab may steel rebar wrapped in plastic sleeves. Concrete block walls are made of concrete masonry units, CMUs. Praise Jesus. Thank you, God. Hallelujah. I love the CMUs. Concrete masonry units are made in varying widths: 12 inches, 8 inches, 6 inches, 4 inches, 10 inches. A typical insulated concrete block, I love that. Slot to allow for easy cutting off block in half, cool. Stretcher blocks, corner blocks. Concrete masonry units are made in 2 styles. Inside and outside surfaces, they increase the thermal resistance. They come in 10 and 12-inch widths and standard height and length of 8 inches separately, respectively. All-weather wood foundations. All-weather wood foundations, AWFs, are made of pressure-treated lumber and plywood. The lumber is specifically treated to resist decay and insect attack when buried below grade. It can be used to support line frame buildings such as houses, schools, apartments, and office buildings. Framing techniques are called the same as the floors and walls. A typical insulated concrete block. Post-cast concrete foundations. Precast foundations provide for fast alternatives to traditional foundation types. They are manufactured off-site and delivered on a truck. They are then craned into place by specifically trained crews. Setup time is typically 1 day. Sections are constructed with insulation and have ribbed construction that allows for additional insulation. This makes the foundation energy efficient. Each section is bolted together and each seam is chalked to produce a watertight seal that is guaranteed by the manufacturer installer. The slab is later placed as a floor to keep the bottom of the foundation from moving toward the inside during the backfilling of the foundation insulated concrete form. A rigid forming system called insulated concrete forms, referred to as ICFs, used 2 inches thick expanded polystyrene units, are manufactured into blocks with a metal or plastic rib system. Block size varies depending on the manufacturers, ranging from whether wall thickness is needed 6 times 6 minus 18 inches, height times 3 minus 4 inch long. The blocks have fastened strips including on their surface to make it easier to screw on walls finished later. Assembling begins 1 course at a time with the corner and straight blocks. The next course is set so the vertical seams are lapped. This interlocked lends strength to the form. Horizontal rebar is installed. As each block layer is installed, vertical rebar may be inserted after the forms are complete. Special reinforcement tape is sometimes used to help hold course of the blocks together. The system is a method of placing. Chapter 29, Foundations and Concrete. Plywood. Plywood sidings, 2x8, typical studs, tongue and groove. Joint plywood floor. Plywood may overlap fields applied top plate for shear transfer. Flat not required as siding overlaps. Chalk, polyurethane film, blocking, floor joist, optional interior finishing. Plywood, face grain direction, 2x4 top plate, field applied. Plywood strip, protecting top of polyurethane film. Asphalt or 6mm polyurethane film strips, polyurethane film. Vapor barrier insulation, bottom plate, screwed board, optional footing, cover plate. Concrete slab, vapor barrier over gravel, coarse sand, and crushed rock. Penetrated 4 diameters plastic of fiberglass drain pipe to store sewer or daylight. Excavation slump pit with 3/4 of larger gravel of crushed stone must be plugged. Perforated pipe, not required to be treated. If backfill is more than 6 inches below bottom of plate, a wood basement floor system is under development. Write APA for preliminary details. Indicated pressure treated method. Vapor barrier insulation, cover plate, footings, 2x footings, screwed boards optional, 2x plate, polyurethane. Vapor barrier optional, interior, floor joist, blocking. Plywood, top plate, fields applied 2x top plate, 5 inches, plywood strip protecting top polyurethane film, asphalt or 6mm polyurethane film, plywood sidings, 4x2 stud typically, plywood floor, tongue and groove joist. Plywood may overlap if field applied top plate and shear transfer. Flashing not required if siding. Caulk the siding. All weather and foundations are made with pressure-treated lumber. Precast concrete foundations are delivered on truck and crane into place. The concrete placement of the concrete is dome in levels of lift. Only one course is filled at a time, giving the concrete time to hydrate or harden slightly, typically by the time placement of the first lift is done. For the entire perimeter, the concrete is made ready to support another lift. Crawl space foundations. In warmer climates like the southeastern United States, crawl space foundations are often used. They are placed under undisturbed soil and only a foot or so below grade and project at least 8 inches above grade. A brick block foundation is a combination of brick and block. It's used below grade and brick for above grade, where it shows the pier and curtain wall foundation uses. Top seams are bolted. Precast concrete panels are fastened together to make the weather and water tight. Weather and water all joints are caulked. Foundations, concrete, and formwork. Insulated concrete forms are used for foundation walls. Insulated concrete forms and assembled in smaller units. Insulated concrete form units are assembled and staggered the butt seams. Piers to carry the building load, and then curtains wall to fill in place with between piers. It can be made entirely of brick. All crawl space foundations are placed on a properly sized spread footing. Proper size depends on the size and height of the building, and it is typically 8 inches wide. Then the wall itself, the foundation is concrete on the footing. Ventilation placed in the top portions of the wall, and the added moisture control is often steel reinforcing is placing with the footings to the building down through the pier foundation. Internal piers to carry beams and girders can be made of brick, block, or precast concrete. Ventilation placed in the top portions of the wall to aid in moisture control is often thought to be good practice. Experiments have showed that it is not. It is best placed to a moisture barrier on ground inside a crawl space. This will allow some moisture from entering the building flooring system. It is ventilated. Brick block foundation, brick piers, foundation concrete, curtain walls between piers, precast piers, block piers, pier and curtain walls. Crawl space foundations may be made with combination of seam and brick piers and curtain walls. Still desired is the best to close them off in the hot, humid season. More on moisture issues from building it may be found in Chapter 50. Characteristics of concrete. Concrete is widely used and it is a material of choice for foundations. Forms are temporarily constructed to contain the following concrete until it sets. Rebar and blockouts for openings such as windows are positioned first. Then the concrete is placed. Understanding the characteristics of concrete is essential for the construction of reliable concrete forms, the correct handling of fresh mixed material, and the final quality of hardening concrete. Precautions about using concrete. Avoid prolonged contact with fresh concrete or wet sunk concrete, possible and skin irritation. Wear protective clothing when working with newly mixed concrete. Wash skin area that has been exposed to wet concrete as soon as possible. If anything material contains cement, gets into eyes, flush immediately with water and get medical help. Concrete is a widely used material. It can be formed into practically any shape. For construction of buildings, bridges, dams, and roads. Improvements over the years have created a product that is strong, durable, and versatile. Concrete is widely used in the construction industry. Composition of concrete. Concrete is a mixture of Portland cement, fine and coarse aggregates, water, and various admixtures. Aggregates are fillers, usually sand, gravel, or stone. Admixtures are materials or chemicals added to the mix to achieve certain desired qualities. When the concrete ingredients are mixed. The Portland cement and water form a paste. A chemical reaction called hydration begins with this paste. This reaction causes the cement to send or harden, referring to as curing, as the paste hardens. Concrete is made up of varying sizes of aggregates, with cement binding them together. And bends the sand, which in turn bends the small and large aggregates. It binds the sand, which in turn binds the small and large aggregates. Together, they form a strong, durable, and watertight mass called concrete. Hydration hardening of the concrete is relatively slow process. Initial setting to the point of being able to walk on it takes hours. It often takes months or more for the concrete to achieve 90% of its full strength. Hydration continues for many years. This process is somewhat fragile. If rapid evaporation or freezing occurs during the curing concrete, the cement hydration process will stop. If this happens, the concrete will never achieve full strength design. Portland Cement in 1924, Joseph Aspdin, an Englishman, development an improvement type of cement. His name is Portland Cement because it produces a concrete that resembles stone found on the Isles of Portland, England. Portland Cement is a fine gray powder. Portland cement is usually solid in plastic-lined paper bags, and it holds 1 cubic foot. Each bag weighs 94 pounds or 40 kilograms. The cement can still be used either after a long period of time as long as it remains dry. Eventually, however, it will be reabsorbed moisture from the air. It should not be used if it contains lumps that cannot be broken up easily. This condition is known as pre-hydration. The types of Portland cement. New developments have produced several types of Portland cement. Type 1, the familiar gray kind, mostly generally purchased and used. Type 1A is an air-entrained cement that is more resistant to freezing and thawing. Type 2, through V, has special uses such as for low or high heat generation, high early strength and resistance to severe frost. White Portland cement uses for decorative purposes. Differs only in color from gray cement. There are many other types, each with its specific purpose, ranging from underwater use to sealing oil wells. Aggregates. Aggregates have no cementing value of their own. They serve only as a filler, but are important ingredients. They constitute from 60 to 80% of concrete volumes. Fine aggregate consists of particles a 1/4 inch or less in diameter. Sand is most commonly used. Fine aggregate, coarse aggregate, usually gravelled or crushed. Some typically comes in 3/8, 1/2, 3/4, 1/2, and 2 inches. When strength is the only consideration, 3/4 inch is optimum size for most aggregates. Large size aggregates use less water and cement. Therefore, it is more economical. However, the maximum aggregate size must not exceed the following: 1/5 of the smallest dimensions of unreinforced concrete, 1/3 of the depth of reinforcement slabs of ground. Maximum aggregate size: 1/5 of smalling dimensions, section through unreinforced footing slab, 1/3 of depth of slab, section through slab on grade, 3/4 of difference between rebars, section through reinforced footings, form boards, 3/4 of distance between rebar forms. Aggregate size depends on the final dimensions of the concrete. Types of Portland cement. New developments have produced several types of Portland cement. Type 1 is the familiar gray kind, most generally purchased and used. Type A is in the air-entranced, and that more resistance to freezing and thawing. Okay, I don't know if we read that or not, but it looks really familiar. Okay, so I think we're going over here. 3/4 of the clear spacing between reinforcing bars or between the bars and forms. Green tab. Some areas of the United States recycle concrete. Concrete is broken into sizes and large aggregates and used in new concrete, replacing crushed stone. Fine and coarse particles must be in a proper proportions that allow the finer particles to fill the spaces between the larger particles. The aggregates should be clean and free of dust, flame, clay, and vegetation matter. Admixtures are available to quicken and retard setting time, develop early strength, inhibits corrosion, retard moisture, control bacteria and fungus, improve pumping, and color concrete, among many other purposes. An important advance was made with the development of air-entrained concrete. It is produced by using air extrained Portland cement or an admixture. The intentionally made iron pebbles are very small. Billions of them are contained in a cubic yard of concrete. The introduction of air into concrete was designed to increase its resistance to freezing and thawing. It also has other benefits. Less water and sand are required. The workability is improved. Separation of water from the paste is reduced, and the concrete can be finished sooner and is more watertight than ordinary concrete. Air-trained concrete is now recommended for almost all concrete projects. Water is the part of the concrete mix that starts the hydration process. It also allows the concrete mixture to flow easily into place. Water used to make concrete must be clean. Other water may be used, but should be tested first to make sure it is acceptable. The chemical reaction of hydration can be negatively affected by water impurities. A good general rule is it is safe to drink and is safe to use in concrete. If it is safe to drink, it is safe to be used in concrete. The amount of water used can affect the quality and strength of the concrete. The amount of water in relation to the amount of Portland cement is called the water to cement ratio. This ratio should be kept as small as possible while allowing for workability. Adding excess water to a mixture simply to increase the flow can weaken the concrete and must be avoided. Concrete strength is measured in pounds per square inch. PSI test cylinders are compressed in large inches to determine how much stress they will withstand before breaking. Typical strength numbers with concrete 25,000, 35,000, 4,000, 4,500 PSI ranging from to low to high. To understand PSI, consider figure. Cube A, the 1 inch and all sides referred to as a 1 inch cube. All columns and stacks are made up of the same 1 inch cubes. Assume cube A weighs 10 pounds. The column B would be 20 pounds. Column C and D would be 40 pounds and 80, respectively. The floor under each column supports the weight of each column, which is measured in pounds. So because each column has the same footing of 1 square inch, the PSI for each is A, 10 psi pounds per square inch, B 20 psi, C 40 psi, and D 80 psi. Stack E has 64 cubes and thus an overall weight of 640 pounds, but does not exert 640 psi on the floor. Notice the columns and C's are the same height. Stack E is made of 16 stacks of C size column. They cover an area of 4 by 4 equals 16 inches, but each of these columns exert 4 psi on the floor. The stack E can be seen to exert 40 psi on the floor using math to solve. This, we take overall weight of the stack and divide by overall area. 640 pounds divided by 16 square inches equals 40 psi. The overall strength of the concrete is determined by many things. It is affected by the relative amounts of ingredients. Water is required for the reaction to begin, but too much water weakens the mix. Also increase the amount of Portland cement increases strength. Aggregate sizes can also affect the strength. Strength of concrete begins with the mix, but is affected by how the concrete is placed and cured. Generally, a slow cure is best because the hydration process is slow. Mixing concrete. Concrete mixtures are designed to achieve the desired qualities of strength, durability, and workability in the most economical manner. The mix will vary according to the strength and other desired qualities, plus other factors such as method and time of curing. For very large jobs such as bridges and dams, concrete mixing plans may be built on the job site. This is basic, fresh mix used in round-the-clock basis. The construction engineer. 81 cubes, 41 cubes, 24, 21, 101, stock on 64 cubes. Each grid 1 square inch. Assume all 1 cube weighs 10 pounds. Cubes are weighed 10 and exert to 10 psi on floor. Stack B weighs 20 and extends to 20 psi on floor. Stack C weighs 40 and exerts 40 psi on the floor. D weighs 80 and 80 psi. E weighs 640 and exerts a 40 psi on floor. Pounds per square inch is effective by weight and area. Calculate the proportions of the mix and supervised tests of the concrete. Ready-mix concrete. Most concrete used in construction is ready-mix concrete. It is solid by the cubic yard or cubic meter. There are 27 cubic meters and cubic yards. The purchaser usually specifies the amount and the desired strength of the concrete. The concrete supplier is responsible for mixing the ingredients of the concrete portion to yield the desired strength. Sometimes the purchases are specified the proportions of ingredients, then they are assumed responsibility for the design of the mixture. The ingredients are accurately mixtured as a plant with computerized equipment. The mixture is delivered into job sites. It transits mixed trucks. The truck contains a large revolving drum capable of holding 1 to 10 cubic yards. There is a separate water tank within a water measuring device. The drum rotates to mix the concrete as the truck is driven to the concrete site. Specifications require that each batch of concrete be delivered within 1.5 hours after water has been added to the mix. If a job site is a short distance away, water is added to the cement and aggregates at the plant. If the job site is farther away, the proper amount of water is added to the dry mix from the water tank on the truck as it approaches or the job arrives at the job mixing concrete. A smaller job may require that concrete be mixed on the site either by hand or with a powered concrete mixer. All materials must be measured accurately. For measuring purposes, remember that a cubic foot of water weighs about 62.5 pounds and contains approximately 7.5 gallons. That a cubic foot of water weighs about 62.5 pounds and contains approximately 7.5 gallons. 1 cubic foot is 7.5 gallons, or 62.5 pounds, and all ingredients should be thoroughly mixed according to the proportions shown. A little water should be put into mixture before the dry materials are added. The water is then added. Ready-mix concrete is delivered on the truck. Uniformly, while the ingredients are mixed from the 3 minutes, concrete reinforcement concrete has high compressive strength. This means that if it resists being crushed, it has, however, low tensile strength. It is not as resistant to bending or pulling apart. Steel bars, called rebars, are used to concrete to increase the tensile strength. Concrete is then called reinforcing concrete. Fiberglass strands are sometimes used as reinforcement to add tensile strength. They are added to the concrete during the final mixing stages. Rebars used in concrete are usually deformed. Their surfaces are ridges. They increase the bond between the concrete and the steel. They come in standard sizes, identified by numbers that indicate the diameter and eighths. For instance, a number 6 rebar has a diameter of 6/8 or 3/4 of an inch. Metric rebars are measured in millimeters. The size, location, spacing of rebars are determined by engineers and shown on plans. The rebars are positioned into forms before the concrete is placed. Rebars in bridges and roads that experience a salty environment, such as seawater and salt during the winter months, have an epoxy coating. This protects the rebar from rusting and thus helps prevent premature concrete failure. The tasks of cutting, bending, placing, and trying rebars require workers who have been trained in the trade. Wire mesh. Welded wire mesh is used to reinforce concrete floors, slab resting on the ground, driveways, and walks. It is identified by the gauge and spacing of the wire. Common gauges are number 6, number 8, and number 10. The wire is usually placed to make 6-inch squares. Welded wire mesh is laid in the slab above the vapor barrier. If used before the concrete is placed, it is spliced by lapping 1 full square plus 2 inches. 1 full square plus 2 inches. Water to cement ratio. Possible strength of PSI. Water gallons. Portland cement bags, 94 pounds a bag. Fine aggregate sand cubic feet. Coarse aggregate size 3/4 max cubic feet. Formulas for several concrete mixtures. Rebars. Placing concrete. Prior to placing the concrete, sawdust, nails, and other debris should be removed from the inside of the forms. The inside surface are brushed and sprayed with oil to make the forms removal easier. No oil should be allowed to get on the steel reinforcement. This will reduce the steel cement bond, thereby reducing the tensile strength provided by their steel. Also, go before the concrete is placed, the forms in subgrade or immersed in water. This done to prevent rapid absorbing of form by the concrete. Concrete is placed, not poured. Water should never be added so the concrete flows into forms without working it. Adding water alters the water to cement ratio, on which the quality of the concrete depends. Slump tests. Slump tests are made by supervisors on the job to determine the consistency of the concrete. The concrete sample for a test should be taken just before the concrete is placed. The slump comes in first dampened and is placed on the flat surface and filled to about 1/3 of the capacity with the freshly concrete. The concrete is then rotted by moving a metal rod up and down 25 times over the entire surface. Two more approximately equal layers are added to the cone. Each layer is rotted into a similar manner, at which the rotting penetrates the layer below. The excess is screened from the top, then coned to turn over into a flat surface and removed by carefully lifting it vertically in 3 to 7 seconds. The cone is gently placed beside the concrete and the amount of the slump measured between the top of the cone and the concrete. The test should be comprehended within 2 or 3 minutes. Completed. Changes in slump should be corrected immediately. The table shown in Figure 2.6 recommends slumps for various types of concrete. Concrete with a slump greater than 6 inches should not be used unless the slump increases admixtures have been added. A slump test shows the wetness of the concrete mix. The concrete truck should get as close as possible. Concrete placed by chutes where needed. It should not be pushed or dragged or more than necessary. It should not be dropped more than 4 to 6 feet and should not be dropped vertically and not angled. Dropping chutes should be used in high forms to prevent the building of dry concrete on the sides of the form or reinforcing bars above the level of the placement. Drop chutes also prevent separation causing by concrete striking and bouncing off the sides of the form. Pumpings are used on jobs larger than needed concrete continuously longer distances or to heights up to 500 feet. Concrete must not be placed at a rapid rate, especially in the high forms. The amount of pressure at any point on the form is determined by the height and weight of concrete above it. Pressure is not affected by the thickness of the wall. A slow rate of placement allows the concrete near the bottom to begin to harden. Once concrete hardens, it cannot exert more pressure than the forms even through the liquid concrete continues to place above it. The use of stiff concrete with a low slump, which acts less like a liquid, will transmit less pressure. Rapid placing leaves the concrete into the bottom still in a fluid state. It will exert great lateral pressure on the forms of the bottom. They may cause the form types to fail or the form to deflect excessively. Concrete should be placed in forms and layers of more than 12 to 18 inches thick. Each layer should be placed, therefore, by setting occurs in the previous layer. The layers should be thoroughly consolidated. The rate of the concrete placement in high forms should be carefully controlled. Consolidation of concrete to eliminate voids or honeycombs in the concrete. It should Types of construction, slump in inches. Reinforced foundation walls and footings, maximum, minimum, plan footings, caissons, and substructure walls. 3. Maximum types of construction, beams and reinforcing walls. 4. Building columns. 4. Minimum. 1. Pavements and slabs. 3. Slump in inches. Heavy mass concrete, maximum. 2. Reinforcement foundation walls and footings. 3. Slump in inches. Recommending slumps for different kinds of construction. Thoroughly worked by hand, spading, or vibration after it goes into the form. Vibrations make it possible to use a stiff mixture that would be difficult to consolidate by hand. An immersion type vibrator called a spud vibrator has a metal tube on its end. This tube vibrates at a rapid rate. It is commonly used in construction to vibrate and consolidate concrete. Vibrations make the concrete more fluid and able to move, allowing trapped air into escape. This will prevent formation of air pockets, honeycombs, and hole joints. The operator should be skilled in the use of the vibrator, keeping it moving up and down and uniformly vibrating the entire pour. Over vibrating should be done because vibrating increases the lateral pressure of the forms. Curing concrete. Concrete hardens and gains strength because of the chemical reaction called hydration. All the desired properties of concrete are improved. For the longer process takes, the rapid loss of water from fresh concrete can stop the hydration process too, soon weaken the concrete. Curing prevention loss of moisture, allowing the process to continue so that the concrete can gain strength. Concrete is cured either by keeping it moist or preventing loss of moisture for the period of time. For instance, if moist cured for 7 days, its strength is up to 60%. Full strength. A month later, the strength of 95% and up to full strength. In about 3 months, air curing will reach only 55% after 3 months and will never attain design strength. In addition, a rapid loss of moisture causes the concrete to shrink, resulting in cracks. Curing should be started as soon as the surface is hard enough to resist marring. Methods of curing. Flooding or constant sprinkling of the surface with water is the most effective. Sprinkling. Pressures of vibration concrete PFS. Rate FT an hour. 1. Columns, walls, columns, walls. Pressure increases as placement rate increases. Pressure increases at lower temperatures. 0 psi, 150 psi, 300 psi. Feet, psi, 300 feet, 450 pounds per square foot. (450 psi). The height of concrete being poured affects the amount of pressure against the forms. Pressure is not affected by the thickness of the wall. 600 psi, 1 hour, 600 psi, 12 feet, 2 hours, 3 hours. As lower portions of concrete begin to hydrate, it begins to support the upper portions of concrete, reducing the lateral pressure on the forms. Method of curing concrete. Curing can also be accomplished by keeping the form in place. Covering the concrete with burlap, straw, sand, or other materials that retain water and wetting is continuous. In hot weather, the main concrete is to prevent rapid evaporation of the moisture. Sunshades or wind breaks may be needed to be erect. The formwork may be allowed to stay in place on the concrete surface, may be covered with plastic film or waterproof. A safe, consistent pour rate is accomplished by using shoes to displace concrete in internally vibrated layers. Concrete bucket, hopper, trunk, the rods, internal vibration, panel joints, 4x8 paneling, whalers, 1 hours, concrete, 1 hours concrete. Right, liquid concrete. Concrete has stiffness sufficiency so lateral pressure is reduced. Wrong, liquid concrete, full height of form. Vibrate only to the depth of the freshly placed concrete. Insert the vibrator too far will cause the concrete at the bottom of the form to remain in a liquid state longer than expected. This will result in higher than expected lateral form pressure and may cause the form to fail. The depth of the vibration should just penetrate the previous layer on the concrete by a few inches. The edges of the sheets are overlapped and sealed with tape or covered with planks. Liquid curing chemicals may be sprayed or mopped on to seal in moisture and prevent evaporation. However, manufacturer's directions for their use should be carefully followed. Curing time. Concrete should be cured for as long as practical. The curing time depends on the temperature. At or above 70 degrees, curing should take place for at least 3 days. At or above 50 degrees, concrete is cured at least 5 days, nearing freezing. There's practically no hydration, and concrete takes considerably longer to gain strength. There is no strength gain while concrete is frozen. When thawed, hydration resumed with appropriate curing. If concrete is frozen within the first 24 hours after being placed, permanent damage to the concrete is almost certain in cold weather. Accelerators then shorten the setting time and are sometimes used. Protect concrete from freezing from at least 4 days after being placed by providing insulation or artificial heat if necessary. Forms may be removed after the concrete has set and hardened enough to maintain its shape. This time will vary depending on the mix, temperature, humidity, and other factors. So next chapter is flat work, foundations, concrete, footing forms. The footings for foundations provide a base through which to spread the load of the structure over the wider of the soil. Concrete for footings, slabs, walks, and driveways placed directly on the soil is called flat work. The supporting soil must be suitable for the type of concrete placed upon it. It must be well drained. The concrete should be placed according to the local environment conditions. Monolithic slab, foundation, wall, tampered pier, footing, column footing, continuous or spread footing, dowel, concrete pedals, wood posts, pier or pile, flared footings, metal column, metal plate. Several types of footings are constructed to support foundations. In stable soils, the soil acts as the footing form.